Moonpig.
Hi everyone, and welcome back to the Moonpig Tech Podcast. I'm your host Ariella, and today I'm joined by fellow co-host Sam.
Hey, how's it going?
And today we're going to be diving into the increasingly talked about trend of vibe coding, what it is, how it's being used, and what it might mean for the future of software development. And today we're going to be joined by two great guests. We have Peter, who's the head of AI at Moonpig, and we have Suche, who's our VP of engineering. So welcome both to the podcast. To kick things off, let's start with some introductions.
Sure. Hi everyone. Thanks for having me. So I lead AI within Moonpig, but I'm also avid vibe coder. So I've got the kind of personal hobbies hat on, but also hopefully professionally what it means for Moonpig. We'll talk about that as well.
Cool. Yep, Suche. I'm VP of Eng for Moonpig, which means I kind of head up the teams that build any and all of the software that we have at Moonpig across each of the different areas, be they web, app, fulfillment, etc. In terms of, I guess, vibe coding, I think it's been a long time since I've written code that went to production, so I'm not going to talk about it from my day-to-day experience. I do write a decent amount of code in my spare time, and it's something that I've kind of been playing with, less vibe coding and more kind of, I guess, AI augmented coding. And so, yeah, on a personal front, it's something that's, super interesting to me. And I feel is something that is a game changer. So it's interesting to have this discussion and see how, personal and professional intersect to talk about where it is that coding is going to be going, or writing, or the art of being an engineer, where that will end up in a few years' time, because I think that's basically what we're talking about here. Like, how is it that GenAI affects our ability as engineers to write, release code, and more specifically to build features that people care about, right? Because that's the end point that we're actually trying to get to. So it's a massive space, loads of discussion to be had, loads of really interesting topics, and it is the thing of the moment, right? I don't think I've been to a dinner or a thing recently where it hasn't been the main topic. Every conference, every podcast that I listen to, every blog that I read, it's a significant proportion of what's being talked about at the moment. So I think this is super timely in terms of the discussion. So very pleased to be here.
Great, thanks for that both. So, yeah, I mean, the elephant in the room, as you mentioned, Such, it's vibe coding seems to be everywhere at the moment. It's on every sort of Twitter post, everything. Can't really move without seeing someone mention it somewhere. So why don't we first get what your definitions of vibe coding are? So what is vibe coding? Peter, why don't you start?
Yeah, I think when people talk about vibe coding, I think they mean quite a range of things. There's on the one side of the spectrum, it could be that I just told LLM build me an app. I never look at the code. I never look at the changes PRs, and I just accept everything and just see what happens. So that's one side. And there's all the way towards the more kind of engineering type of vibe coding, where you might give some specific instructions. You've got already a code base that you're working with, and you want to then make some changes to it. You're not necessarily writing code, but maybe you're just specifying exactly what you want done. Then you check the code, run tests, you do a lot more work, and you are much more informed about what's actually happening. And then you can also accept decline PR, and that's much closer to the kind of much more real engineering, or kind of being more kind of engineering manager in a sense. And there is definitely somewhere in between as well. And I think that there's definitely a scope for confusion, where sometimes some people, maybe more engineering type people, talk about vibe coding or coding with LLMs, and they mean more the latter. But some people would mistake it for, oh, I'm just talking about, I'll just ask the LLM to build me the new feature, and I just sit back and drink my coffee until it's built. Which definitely does not work, which I know we'll get into a bit later. So yeah, there's definitely a range.
Cool, thank you for that. And so, Such, why don't you give us your definition of what vibe coding is to you as well?
Yeah, so for I think it is more along the lines of the second definition that Peter gave, right, which is essentially you talk to something. You say, I would like you to build me or create me X, Y, or Z. It creates you that thing, and anything that it creates, anything that it builds is entirely a black box to you. So you don't need to know or care or understand what it is that it's built or how it is that it's built. All you care about is the output, what it looks like, what it does. And it's very much, that's like the very, very end of the spectrum. And that to me is the pure actual form of vibe coding. It's the definition that generally, I believe, when you're on the internet, that's the general definition that people are talking about. And then again, as Peter was saying, I think there's a sliding scale going from using things like I don't know, Code Whisperer or Copilot all the way up to that, and all of those other things I look at as being augmented, coding essentially. So you augment your own ability, your own time, whatever, with Gen AI, and it makes things easier or faster, or of a higher quality, or any of the other things that you might want. But essentially, there's still an engineer who is the person who directs and controls and understands the output, and that's the important thing. It's very much about understanding the output that comes from that you create essentially. And so to me, there's a very, very clear and obvious line between vibe coding, which is what anyone might do. Like I could have an 8-year-old say, hey, build me this thing. They do not care, and are not supposed to care about the output. They're not necessarily supposed to care about, how it's done, what are the different repositories that stuff gets pushed to, what are the different languages. They do not care. Like, why would you? And then there's everything else, which does require some amount of intervention and input. And that's, like I said, what I put in that augmented bucket. And that's, I think, the majority of the useful code that is being written falls into that. Well, no, all of the useful code, as far as I can say, I'll take a stronger stance. All of the useful code that I've seen written falls into that bucket. And yeah, vibe coding is more just to be able to do cool things quickly. It's not something that's extensible. Generally, it's not something that you would expect to be able to build upon or scale. Generally, it's it's a tool, and it's a useful tool, but it's not necessarily the kind of thing that I would expect to be used on a code base that currently exists, for example.
Great. So I think we've got a pretty decent understanding of what it means now. So I wonder if we could talk about, we've gone into a little bit of it already in terms of examples. I was wondering if we could go deeper into those examples. So, Peter, why don't you speak to us a little bit about how one might use vibe coding, particular examples?
Yeah, so, and I don't know if Suche will classify it as vibe coding or not, but I've definitely built some prototypes where we got them all the way to user testing, which I would build 100% of the code was written with LLMs. And I guess where maybe it gets like a little bit muddy is where I still need to understand how it would work roughly. So for example, I know which APIs am I hitting, like how are we storing the images, how is the database structured so I can later retrieve the data so it's actually useful for me when we're doing user testing. So it does kind of get a bit grayer how much you're supposed to know about the application. And I think if we kind of exclude the one short social media level applications, then I do feel like you have to know how it's built, and you have to be able to do things like debugging, and you need to see, I know, even things like just basic things like look at the console and like look at the logs and what's failing. I haven't yet managed to succeed building anything of beyond this kind of tic-tac-toe type of games that just works completely out of the box, and the LLM's not quite there yet. So having a good idea of how you build something, debug something, I think is essential. Especially, so if I give example of the initial prototype, so we built the AI stickers feature. Now it's in production, but the way it started was that we had a couple of different prototypes. The very first prototype was that I built, kind of vibe coded, but it was a working prototype. But the way it had to actually use the models that I wanted it to use, it had to be roughly, it had to have an outline of a production product that we would have. But maybe to Suche's point, like, it didn't really matter how it was built precisely. Like, as long as the few key points were built correctly, like that would mirror how we would build it, then that was enough. But in terms of what front end it was using exactly, or like whether the code base was modular, like that stuff didn't matter. So maybe that's also another interesting dimension where at least right now, I think it's not really possible to expect LLMs to just build something completely perfect that you just have in your head. So you need to specify that a bit more precisely. You need to, I don't know, give it documentation of the things that you want built. But it only matters in certain key dimensions. But in some cases, maybe 80% of it doesn't really matter. So whether even basic things like whether I use, I don't know, TypeScript or Python, like I don't really care. Just do something that works. Yeah, so it probably would vary for different people, but at least the examples that I was working on, where I care about getting to the outline of the application that works in the way that I imagine it, that's how I approached it personally.
That's really interesting to hear, especially about the prototyping example. So, Suche, do you have anything to add on that? Any other specific examples you'd like to bring up?
Yeah, I mean, I think, again, sticking to the kind of the idea of vibe coding, of it being a black box, I think it's very, very, very useful for things like prototyping. I think it's very useful for doing real life live proof of concepts in a way that, and it enables a bunch of use cases that wouldn't have been enabled previously, right? If you were a designer, you create something with Figma, maybe you had various different frames, and it had some amount of ability to ape what it's like using that product in real life. Now you can just say, build me these 10 different variations. You know, you give whatever tool you're using a set of reference images, you describe the kind of behaviors that you want, and it then gives you the ability to prototype out in the time that it would have taken you to build one thing, 10 different various options. Each of them may be slightly different, each of them perhaps wildly different. Depending on what you're using, it then gives you the ability to send that out to multiple people, and you can share it in a way that means that it's fully interactable. And so I think it's really, really good for that kind of thing, for quick turnaround, prototyping, testing, providing real life usable apps, websites, whatever, that give you the power to actually fully show something to people in a way that it didn't previously. I think it's also great for playing with new technologies or with new languages, because even though you might initially say, build me this thing, you don't necessarily care what the code looks like, for example. That doesn't say that you can't then take that as, you know, a bootstrap or baseline for something that you are planning on building, right? So it gives you the ability to kind of get started in a way, you know, bootstrap yourself in a way that you wouldn't have been able to previously. So I think there are massive, massive use cases where it's very, very, very helpful. I think when you combine that with kind of the augmented model that we talked about, that's when it's probably most powerful. So again, taking the example of being able to build things that you maybe wouldn't have been able to previously, it's really great for learning a new language. It's really great for, like, you can say, build me this thing, give it a spec, etc., and then you can then use the kind of augmented model to continue to work on that in order to build out something else. So I think that at the moment it's got tons and tons of use cases. Those use cases only continue to grow. So there's going to be more over time. And I think, honestly, in future, and I don't know how far we're talking about when we say the future, I think what we call vibe coding will probably be a significant amount of what is just coding. You know, like it will be engineers working with multiple frameworks, LLMs, whatever, to to describe and prompt into the right sequence of things that mean that you have useful functioning customer facing software at the end. I think that's a ways down the line, but I think kind of getting used to that paradigm is only going to be helpful, because it is something that I do see being probably the not too distant future, because I think the role of engineers will change as part of that, and engineering will be different now different in 15 years than it is now, in the same way that it's different now than it was 15 years ago when I was still writing code, or 15 years before that when we were, I guess that would have been 30 years ago. So we're talking about mainframes and whatnot, right? It's a very different landscape now. The role changes and evolves with the technologies that we have and the tools that we have, and so I think it's a thing that's going to happen, and it's just a matter of how quickly we can get on board with it, essentially.
Yeah, I completely agree. And I guess another part, as we zoom in more to the engineer side, I guess there must be a bit of a concern about the engineer's day-to-day responsibility. I guess we're going to be spending a lot of time kind of using these tools, and we'll have lots of kind of engineers relying on this AI generated code, and they're probably not going to, like you said, always understand what it's going to do, and they might not have that kind of in-depth knowledge on kind of engineering principles, let's say, like I think we've mentioned already, like our testing, our architecture, our clean code, and things like that. So, yeah, if we can zoom on in onto the engineer side, how would you guys say this will affect the engineer's growth and skills over time?
I think this is something that people concern themselves with a little bit too much. Like, again, writing code now is very different than it was a few years ago. So if anyone's ever written any C or C++, you don't have to do any of the like memory allocation and pointer manipulation that you do in modern languages, right? No one's concerned about that kind of stuff when we talk about using, I don't know, JavaScript. It's like everything's processed dynamically. You don't need to worry about memory allocation. It's a very, very different paradigm writing code now than it was 25, 30 years ago. And if you look back at when the first sets of computers were created, and we're talking about these giant things that took up entire rooms, and you had literal actual bugs like creepy crawlies that would jam up the machinery that caused things to fail. Like, that is again a very, very, very different paradigm that was in use compared to 30 years later. And so the job of programming has changed already so many times, and each time there's this kind of concern, right? Oh no, we're functional languages are too high level. Well, it just means you can get more stuff done with less code, hopefully. The role necessarily changes over time, and the way in which the importance of different skills changes for that role over time as well. It's a constantly evolving thing, in the same way that language constantly evolves, right? It never stays the same. The English language now is very different again than it was 30 years ago. So I think this is a problem that's kind of overstated. People adapt, people always have adapted, people always will adapt. The role has changed and continues to change, and so what it means to do the role will probably be different in a few years' time than it is now. It's perfectly normal. It'd be weird if we were in some bizarre stasis where it hadn't changed, because that would be counter to the pattern that we've seen since the inception of computing. So I'm not at all concerned. I think we're subject to like the circling of the wheel of time, and so we get caught up in it in a way that people don't really understand or realize, because they're in it. But we're all literally in it right now, and so yeah, it's not something that worries me. The only thing that we have to do is ensure that we are bringing people as many people as we possibly can on the journey, because the worst thing that we can do is not take note of the fact that things are changing There are always people at any juncture in time that are kind of, lost to the inability to move with what's kind of coming before them. That's all that we need to do. The only thing we need to do is ensure that we're aware and cognizant of what's happening, and we make the best of efforts to help teams and people evolve with the times. But again, that's a thing that we naturally do. Like this is generally not something that I'm particularly concerned about, because we've seen it happen so many times, and we've always managed to kind of push forward and move with the evolution of the art or the science or whatever it is that we've had to. So yeah, it's not something that I'm particularly concerned about, even if people in general, I talk to people, some people are concerned about it. Everyone was concerned at the invent of the internet as well. Are we going to be able to do this? Are we going to be able to move at the speed that we need to? People were concerned when steam engines came in. People were concerned when the plough was invented. Like we've seen these inflection points so many times, and each time we've managed to push through. So it's not something that worries me at all, if I'm completely honest.
Nice, thank you for that, Sush. Peter, have you got anything to add? How would you say the growth of an engineer is going to change with this new technology?
Yeah, I think there are definitely, I agree with Suche. I think it's not going to go away, but it will be probably quite different in terms of what specific things that matter, and maybe the mindset of the a good engineer will change. So there's the reality right now is that it's really hard to keep up. So if you've tried language models maybe 8 months ago for coding and you sort of didn't like it for whatever reason, now actually things are quite different. These models are actually really different, especially the thinking models, the reasoning models are substantially better for coding than they used to be. So there's definitely one aspect of it. Another aspect of it is that the type of there's always kind of bottlenecks in any technologies, and the bottleneck maybe before was knowing how to write code specifically, and now that bottleneck is not really there. I mean, it still will be for maybe harder languages or more harder features to implement, things like that, but that kind of bottleneck moves further out. Then you get the next bottleneck, and the next bottleneck is knowing how to write like good production code and how to architect the system well, and how to think about trade-offs and maybe structuring the code base well so you can actually make changes with LLMs without breaking everything. How do you architect tests in the right way to make sure that whatever you if LLM does create some bad code, that nothing falls down. So all of those skills don't automatically come with LLMs, and also it's a little bit unfair to expect language models to be good at that. Not because they might not know technically, but you would have a lot more context about what you're trying to build. Who is it for? Is it important that you do this or not? Like the common thing, by the way, when you kind of vibe code and you ask the LLM, or is there anything wrong with my code? And it starts going on about security, about scalability, and all of that. And you're like, oh my God, this is for 3 people. Like, why am I putting some crazy security tokens and so on just to kind of... So you would have a lot more context about what is it that you're building and why certain things matter and so on. And a lot of the advice that the LLMs would give is completely wrong. Not because it's wrong in abstract, but it's just wrong for what you're trying to do. Then there are some very specific things about like, and actually it would be interesting to get Suche's opinion whether it's like vibe coding or not. There are things like Codex from OpenAI and this as well, where it's a kind of coding agent that does the work on your behalf, and all you need to do is basically after you submit the issue, you then check the PR. So, and it works pretty well with larger code bases. It's actually better for larger code bases than completely new projects. And for this to work, what you actually need is like pretty well structured code base so it can navigate your code pretty well. Then you actually need to have really well specified issues. So if you're just generally saying, or just, have a look at the app and fix it, like that will not do anything or of any value. But you could kind of say this to the developer and say, or just like have a look around, see, like tidy it up. Like maybe you could do that. So certain maybe ways of working, how you organize your work will change a lot. Another thing that I've heard, but we haven't tried, I would say, yet at Moonpig at any kind of reasonable scale, is I've heard labs talk about, so like Anthropic, OpenAI people, where they would run these agents in parallel. So they would have, they would build towards certain feature, and they would specify, and they would have like 3-5 instances of them running, and then they could pick the best one or just discard them, or maybe have them collaborate. So there's also another dimension of being kind of a manager of LLMs, of how do you actually coordinate them. And for that to be like a good engineering manager, you need to know the code base and say, okay, like I'm gonna put this agent here so they can work on this code base, the other agent here so they don't overlap. So you also need to imagine how that should be built as well. So yeah, I think I would say that there are probably some things would matter less in the short term in terms of like knowing the syntax, and other things, as these bottlenecks go away, there will be many more bottlenecks about like knowing what to build, how to architect it, how you do coordinate, how do you run tests, how do you structure things. So these sorts of things will become the new bottlenecks, and it's hard to immediately imagine how LLM is just going to overcome all of that. It's much more about like structure and organization, which we still need to do.
It's really interesting that you raised the idea of, I guess, because we haven't talked much about agentic sort of workflows, because the way I've been breaking it up in my mind is essentially 3 parts, right? Or 3 levels, 3 areas, I don't know what you want to call them. The first one is what we've currently been using fairly heavily, which is kind of this augmented copilot-style model where you're there and present during all of the code that's being written as it's being written. And you kind of, it's a little thing that hovers on your shoulder that helps you build out, whatever it is that you're building out. Then there's a kind of second level, which is the agentic level that you talked about, where you're still responsible, I guess, for all of the code that is submitted. But, you maybe task something with going away, completing a task and coming back to you, and then you look at the results, and then you're like, oh, maybe this bit needs changing, maybe this bit needs changing. And that kind of goes to that model that you talked about, which is around being a kind of coordinator, like having a centralized coordinator that knows how to manage the various different inflows that are coming from the multiple agents that you might be managing across any given project or timeline. And then there's the last kind of level, which is, I guess, akin to what we're calling vibe coding at the moment. But it's where you just don't care. Everything is written by, something, an LLM, set of LLMs, whatever. And that manages all of the writing of the code, and perhaps there are multiple agents that it also manages, but realistically you're there more in the capacity of understanding and building out requirements. Having taste, I think, is one of the things that's kind of important, be that as in terms of design, like actual architectural design, or digital design or whatever. And I think that then becomes way more important, and you then act as that kind of coordinator. And so those are the kind of 3 areas that I've been breaking it up into mentally. And I think we're kind of very much in the first phase. Everyone's using things like Copilot or Amazon Q Developer or whatever. We're starting to move into that kind of agentic side of things, but there are some issues with it. And one of the things that you mentioned was code base, like readability, documentation, etc., like essentially understandability or discoverability. And then the eventual evolution into, we don't really need to know or write code as people anymore. Don't know how far down the line that's going to be, but everything's written by something. That's obviously quite a ways from where we currently are at the minute. The documentation one is a super interesting point to me. I think I think I would prefer, and I don't know how feasible this is, but my preference isn't that we are in a situation where we have to have code bases in a very specific structure to support the LLMs that we want to be able to read them, but more we develop LLMs that are good enough at being able to understand the code bases that we have. Like there are two very different kind of approaches to it, and I think fitting stuff around us rather than fitting us around stuff is the way that I would prefer to do it. When we eventually get to a point where everything is written, by GenAI, that whole point becomes moot. But in the interim, there are so many code bases out there that would be rendered entirely useless to GenAI if we have to have them in a certain format, that I think the utility comes from being able to create stuff that is good enough to understand and parse with, the relevant documentation, what it is that we the current state of play, and then work from there. So given a choice, and I'm not 100% certain as to how feasible this is, that's the direction that I would go in. And I think that's like, if I were OpenAI and I could build some sort of agent that could understand the code bases that currently exist via some set of, a mixture of being able to crawl repositories and understand the various different sets of documentation that are about and all of the other things, that to me would be worth trillions. Like it would be worth so much money. That's absolutely where I'd be putting my bets, but how difficult that is to do, I'm not 100% certain. And then on the coordinator point, I agree that I think in future, that is, again, when we get to a position where that's how everything gets built, that's how everyone writes. I think you're right, that's more the job of an engineer in however many years' time, right? It's understanding and being able to work with multiple different agents, being able to issue instructions that are clear, concise. Again, the thing that we mentioned around having design taste. And then you possibly get to a situation where everything is in one. So like, is there an engineer? Is there a product manager? Is there a designer? Don't know, maybe everything is in one, and the only thing that matters is taste, right? Your ability to come up with the right ideas and your taste. And so what are the things that you have and understand that will allow you to build a product end to end? I think that becomes super, super important, and you get a massive blurring of the lines between all of the current roles that currently exist, right? And then maybe just going back to the idea of, and this is something that we've talked about a little bit as well, is the idea of correctness, I think. And I think this is the one of the things that you mentioned, Peter. I think correctness is the one thing that we're not necessarily talking about a huge amount. Because you're right, you can have LLMs build you a whole bunch of stuff, but without having a way, some test harness to understand with our current capabilities how much of that is good versus how much of that is garbage or not necessarily garbage but suboptimal, shall we say, is one of the things that is super important right now, and that we probably need to continue investing in, because it's very easy to leap from where we currently are to this idea that you can have a whole bunch of code that is written for you that will do the thing that you want. Will it do it correctly is one important question. Will it do it in a way that is efficient is another important question. Without understanding how it is we tackle that problem, and without having the right level of expertise to know when it is that you have code that works but isn't necessarily the best versus code that works and is super efficient and super readable, I think that's where at the moment most of the gains that you see, and I've had conversations with multiple people around this, I think senior developers, even though they tend to be the most resistant to working with working in this augmented fashion, are the ones that benefit the most, because they have enough expertise to be able to tell when something is good versus when something's not good. when the code that's been generated is useful, sensible, and when it needs to be tweaked. And so they can see massive performance or productivity increases, assuming they can just be bothered to learn and trust the tools. Whereas I think it's maybe a little harder as a junior developer to understand correctness. And so I think it's really great for learning, but I think you don't necessarily see the productivity boosts immediately with more junior developers, because you still have to develop that understanding, at least at the moment. And again, I don't know where this will be in 15 years, 10 years, whatever, but you still need to develop that understanding that allows you to, smell bullshit, essentially. And so it's going to be interesting over the next however many years as we get more and more people, using GenAI. Because I think it's good at all levels. I think as a productivity boost, it's more for senior engineers at the moment, or your senior mid-levels, whatever. I think for junior engineers, it's not so much a productivity boost, but it is definitely an experience and learning boost, which means that they can become more experienced more quickly. They can gain, knowledge more quickly. They've got someone or something there to anthropomorphize. They've got someone there that allows them to ask the types of questions that it's really helpful to be able to turn to someone and ask, and then they can kind of verify those assumptions or the input that they get back with other engineers in order to help prove correctness. So yeah, that was kind of a mashup of maybe randomly assorted answers to some of the stuff that I think you said, Peter.
Great. Well, that brings us to the end of today's episode. So thank you so much, Peter and Sush, for sharing your insights on vibe coding and the future of engineering. And we will see you all next time on the Moonpig Tech Podcast.
Moonpig.